So today's lesson is about comparing data sets and outliers. And in order to do that, you're going to visually see if something's an outlier and then verify them algebraically. And then on your practice, it revisits, which one's a better measure of spread and center. So that little chart we filled in at the end yesterday. And then calculating the mean, which we also did yesterday. So I'm assuming you guys are pretty good at that by now. There's also other questions on the practice. I talk about if it's symmetrical, if the box is really big or really small, what does that mean about the data? And it does revisit that on your Module 6 quiz. So just be aware of that. You do need to be able to interpret these graphs. There is a video on Schoology that you can watch if you want an extra reference, or I'm uploading right now, or I'm recording right now and I'll upload it later. The puzzle piece that is assigned to this practice or this lesson is 6.03. And then you have the Module 6 quiz scheduled for Monday. All right, so we started that Wednesday. It's scheduled for Monday. So you need to be able to understand and interpret dot plots, box and whisker plots, those 5 needed values, and comparing data, things like that. Any questions? All right, so Monday's a short day. There's only 30 minutes. So once you come into class, you need to get your lockdown browsers up and ready. All right, so we're just have a quick, easy lesson today about outliers. And the goal is to have a lot of time at the end for you to work on your puzzle piece and the other one from the past few days. It looks like Schoology is being a little finicky right now. It goes in and out, but hopefully it works by the time we're done with this lesson. So first thing that you need to fill in is what an outlier is. All right, so an outlier is a value in a data set that is much greater or much less than most of the other values in the data set. So the outcasts, they're really far away from the rest of the data. And those are potentially bad because they could mislead the data. They could say that the average is much greater than it actually is. All right, so much greater or much smaller than the rest of the data. You can kind of determine that visually, but you can also verify it algebraically, which is what we're going to be looking at today. And to verify it algebraically, you need to use the first or third quartile. So what is that first quartile abbreviated as? Q. And the third quartile is abbreviated as. We'll be using either Q1 or Q3. And we're definitely using the IQR. So what's the formula for IQR? Q3 minus Q1. All right. Now, in order to figure out what my Q1 and Q3 is, what value do I need? Or what value do I need to figure out first? The median of the whole thing. So you need to know how to find the median, which is also known as what? And Q2. All right. So we talked a lot about this yesterday. You're going to see it a lot again. Here is the formula for how to verify that something is an outlier algebraically. All right, so if we have a data value, and we'll call it X, but it'll be replaced with whatever number you're told to figure out is an outlier or not. The X will be an outlier if it is either a lot smaller than the rest of the data or a lot bigger, and there's a different formula for each one. So you use the one that has the less than if the number is significantly smaller than the rest of the data. So fill that in. You use that first inequality if the value you're evaluating is significantly smaller. And you use this one if the value is significantly larger. So we're going to look at an example that we actually looked at on Wednesday, and it was a list of salaries for a particular company. But now that list is expanded to include the owner's salary of $150,000. So now the data points are what they were originally, but now also 150. To evaluate this, we need to choose an appropriate scale by looking at what the smallest and biggest values are. And there's actually a mistake here. What is the minimum value? 20, not 25. All right, so kind of fix that. 20 is the smallest value. And then because we changed the data, it's now we have a new maximum, which is 150. All right. So we need to create a number line that now includes our new data point. So it says down here a number line from 20 to 160 will include all the data points. And a scale of 5 will be convenient for the data. All right, because the data goes up by 5s, right? There's no numbers in between these. All right, so they already made the number line for you. So all you have to do for this part is to plot these data points on this number line. So take like 30 seconds and do that. So plot each point on your number line right there. So we have 25, 20, 35, twice, 40 twice. So plot your data so you can look at the distribution. See if it's more symmetrical, more asymmetrical. All right, so what are we noticing about our distribution? Is it all like in the same area, the numbers? Are they like really spread out?
They're more smaller.
They're more on the left side, and there's one value that is really far away, right? So visually, which one do you think is going to be the outlier? Which? The 150, right? It's a potential outlier. Looking at how far away it is, I'd probably go ahead and say that it is. But you can also determine it algebraically. So scrolling down, we are going to determine if the 150 actually is an outlier by using that formula, one of the formulas at the top. Which one are we going to use? The one for the smaller numbers or the one for the bigger numbers? Bigger, because the 150 is a lot bigger than the rest of the data. So copy that equation over. I believe it's x greater than Q3 plus 1.5 times the IQR. All right, and then we need to fill in what we can for that inequality or equation. So what number is going to go in the x position?
The 150.
The 150, good, because that's the number that we're evaluating. The x is going to be whatever the outlier you think it is. So 150 goes there. It's going to be greater than Q3. Well, do we know what Q3 is? So we need to figure that out. So what should I do in order to figure that out? Put the numbers in order. And I'll kind of use my dot plot to help me with that since, you know, they are in order on the dot plot. So we have 20, 25, 35 twice, 40 twice, 45 twice, 50, 60, and 150. All right, I have 11 data points, which we started with 11 data points, so that's good. All right, now find, can I just figure out what my Q3 is right away, or what do I need to find first? The median of the entire thing, right, my Q2. So do your underlining on each side until you get a middle number or a middle two numbers. And because we have an odd number of data points today, we haven't done one together where it was an odd number of data points. You should only have one number in the middle. All right, so my median of the entire data set is 40. So I'll label that as my Q2. So now that separates my lower half and my upper half, so we can figure out the Q1 and Q3. And we haven't done an example where there was only one number in the middle. So just to show you, when you're doing your underlines, you're not going to underline that number when it's only one in the middle. All right, you just kind of ignore it, pretend it's not there, and find your median of your lower half. All right, so what's the median of the lower half?
35.
Good. 35 is my Q1. And then think in your head, don't say it out loud. What would the Q3 be? Good. All right, so we identified those other numbers that fit into here. So Q3 we said was what? 50. And then plus 1.5, which we originally had, times the IQR. Well, what's the formula for IQR? I'm going to put Q3, which was 50, minus Q1, which is 35. All right, now you could solve this by hand on the right side, or you can put it into your calculator. Whichever one will get you the right answer, I'm perfectly fine with. All right, so enter the right side of the inequality in your calculator. And then tell me what you get when you do that. All right, you can fit the whole thing in your calculator with the parentheses and everything. All right, anyone have an answer for the right side? Good. It is 72.5. Good. All right, so that's what I get from putting the entire thing in my calculator on the right side of the inequality sign. Now look at the statement that we have here. Is 150 greater than 72.5? All right, so this is a true statement. When you get a true statement, then that means the outlier that you were evaluating is an outlier. All right, it's significantly greater than the rest of the data. So in order to qualify, any number that's greater than 72.5 will be an outlier for this set of data. All right, so 150 is an outlier. Questions about that? Yes?
So when your numbers, the outlier is bigger than the rest of the numbers, constantly you use the bigger one?
Yes. And if it was smaller, you would use the formula for the smaller numbers.
I don't understand how you got 1535 and
This?
Yeah.
50 minus 35?
Yeah.
Because the IQR, the formula for that is Q3 minus Q1.
Oh.
So then 50 minus 35. All right, any other questions? So if this statement was false, then it's not an outlier, but it's true. All right, I'm gonna have you try the next one, and I'll leave this up so you have a reference. But the one I'm having you try is part B of this. So it's the same real world situation. We're still talking about salaries, except we're changing the owner's salary to 65,000. So now we're seeing if 65 is an outlier. So what formula are you using for that one? The one for the bigger numbers or the smaller numbers? The bigger numbers. All right, so the same one that we did. So I'm going to go back to the first page so you have a reference where you're completing part B as the your turn. Yes. All right, so you guys are correct. It is not an outlier, and that is shown right here in case you got stuck or you got a different answer. So yes, you use the same formula that we did in the last problem because 65 is greater than the rest of the data set. So it's for larger values, that formula. X is the number that you're evaluating. You got the same Q3, it's mostly the same data, but here it is down here. We got the same Q3 plus 1.5 times the IQR, which also happens to be the same because of the Q3 and Q1. We got is 65 greater than 72.5. That is not true. That's false. So that means that 65 is not an outlier. All right, does that make sense? All right, we're going to do the next one together because that one is for smaller values. So we'll at least see what one of those looks like. All right. All right. So we have baseball pitchers on a major league team throw at the following speeds in miles per hour. And they're not in order, they're in random order, but starting at 72, 84, 89, etc. We need to create a dot plot with an appropriate scale. So this time they didn't draw up a number line for us. We have to make it ourselves. And determine whether the extreme value is an outlier. So they didn't even tell me which value they want us to look at. So first, let's make our number line for our dot plot. And we need to figure out what we want our dot plot to start at and end at. So what's a good starting value? I would say 70, just because it's all right for it to be like a little bit bigger. All right, so we'll start at 70. And what should it end at? About 100, or maybe even a little more. Maybe like 105. I don't know, 110. And how do we want to count by? We want to count by fives again. What do we have to do? I've never heard of that. Just kind of picking an appropriate scale for our tick marks. We want to count by 1, 2, 3, 4. I would agree with Zachary that I would count by 1. Because you see how the data, it's not like all going up by 2s, it's not all going up by 3s, it's not all going up by 5s. If we were making a dot plot, we want to show like all the dots. So what I would do is go up by 1, but I'd probably only label like every 5th one, if that makes sense. So we'll do 70 and 71, 74, 75, 6, 7, 8, 9, 80, and then just keep going like that. All right, so make your number line right now. Mine happens to fit nicely, but yours, I'm gonna have to erase a little bit. All right, so once you've made your number line with an appropriate scale, plot your dots or your X's. All right, so make your number line and your X's, your dots. When you're finished, compare yours to mine. All right, so looking at our dot plot, where is the data mostly distributed? So like in the middle, right? And then we have 2 potential outliers. So what's one of 3 potential outliers? And good. And it wants us to really just figure out whether the extreme value is an outlier. So I would just determine like what's the space between the first outlier and the other data point, like how much is it between 72 and 8 or 7, about however you're counting. 72 is 8 away from 80. And then what's the distance from 94 to 100? I think that's it. forgot to tick mark in there. So what's the distance from 93 to 100? 7. So which one is more extreme, 72 or 100? So we're going to determine if 72 is an outlier. Does that make sense? All right, so is 72 an outlier? What formula will we use to determine?
Small
X.
Good. We use the one that is less than, because it's for the smaller value. And notice it doesn't use Q3, it uses Q1, because that's the lower quartile, right, for the lower numbers. So that'll help us figure out if 72 is an outlier, because it's a lot smaller than the rest of the data. So what will the X value be? Good, because that's the number we're evaluating. Do we know what Q1 is right now? So we need to order the numbers, right? So we need to kind of list them all out. I'll use my dot plot for that. They're already in order for that. So we have 72, 81, we have 84 twice, 86, 87. Did I count that right? Nope, I did not count that right. So that's on 87, not 86, sorry. And then 88, 89, 90, 93, and 100. All right, and then I have 11 data points, just like the ones I started with. All right, so to figure out the Q1 and Q3, I need to find the median of the entire thing, right? So figure that out first. Do your underlining on each side until you get a middle number or middle two numbers. And the Q2, the median is 87. All right. That separates my lower set and my upper set of the data. So now find the Q1. The Q1 is what? And then find your Q3. So the Q3 is good. So fill in the rest of your formula. You said the Q1 was 81 minus 1.5 times the IQR. What's the formula for IQR? Good. So I'm going to write in 90 minus 81. All right, enter the right side of the inequality into your calculator, or solve it by hand. As long as you get the right answer, that's fine. All right, tell me what you get when you enter that in your calculator. $67.5 is what you get when you enter that in the calculator. So is 72 less than 67.5? So this is a false statement. So is 72 an outlier?
No.
Good. For it to be an outlier, it would have to be smaller than the 67.5. All right, any questions, comments? Yes? You would not have to evaluate the other one because that one's even closer to the data than the other. All right, so it would not be an outlier on the other side. Yes. All right, any other questions? So here's a good question that you might see something similar to on your test, this reflect question. So if the mean, remember the average, increases after a single data point is added to a set of data. So we already knew what the mean was, we just added data point, now it's larger. What can you tell about that data point? So would it make more sense that if the mean increased, that the data point is bigger than the data or smaller than the data? All right, the new data point is larger than the rest of the data. All right. So that's like the same style questions that would be asked on your quiz for this Monday. Like if I have these two box plots, which one has a greater mean or median? Or what happens if I add something to this box plot? Does the mean increase or decrease? All right, so you have plenty of time now, 23 minutes to work on the puzzle piece for today, the 6.03, and also to work on the ones from the past 2 days if you did not finish them. If you need extra attempts, like you used all 2 and you still didn't reach that 80% or 100% that you want, let me know and I will give you another attempt.